Good morning, everybody. This is going to be video number 95. This is going to be all about gravity. So let's start by talking about what a force is. A force is a push or pull, and gravity is a specific kind of force that pulls on objects.
What goes up must come down. A ball you throw in the air, an apple that drops from a tree, even you when you're on a trampoline at someone's awesome birthday party. But why? My friends, let me introduce you to one of the most wonderful forces in the universe. It's one we're all experiencing right now without even trying. Fasten your seatbelts because we're going to explore the power of gravity. If I told you that you just won the lottery, what would you do? If you're like me, you'd jump up and down and scream. And after you were done freaking out and jumping in the air, you'd land on your feet, right? But why would you land back on the ground instead of just floating off into space? It's because of a little something we call gravity. Gravity is what pulls everything toward the ground, including you. Without the force of gravity, there would be no life on Earth. Air, water, animals, everything would fly off into space. There'd be no you, no me, no French fries, nada. Think of gravity like the invisible superglue that holds our massive world together. You can't see it, but it's always there. An English scientist named Isaac Newton was the first person to seriously study gravity over 300 years ago. There's a famous story about him that you might have heard. Supposedly, Sir Isaac was hanging out underneath an apple tree thinking, probably partly napping, when an apple fell from the tree and conked him on the head. That's when Sir Isaac had an aha moment. Why did the apple fall down to the ground and not up or sideways? He realized that a special kind of force, which we now know as gravity, was acting on all of the objects on Earth, pulling them toward it. Once the apple became too heavy for its stem to hold it anymore, the gravitational pull of Earth brought the apple down onto Newton's noggin.
All right, hope that video clip helped us define gravity. Now, gravity needs mass. That is very important. Those two things go hand in hand, like burgers and fries or peanut butter and jelly. So gravity is a force that acts on any object that has mass. So no mass, no gravity, okay? It pulls towards the center of the Earth, not down. So this is one of the reasons why a lot of people ask, why don't we fall off the edge of the Earth? This is because of gravity, because gravity pulls you towards the center of the Earth, not down. Now, when you are talking about astronomy, more is better, or bigger is better. So more mass equals more gravity. Now, this is really important when we're talking about our sun. So look at the comparison that I have for you here. I've got let's try that again. 1, 2, 3, 4, 5 objects. And I've got the sun, I've got a low mass star, a brown dwarf, I've got the planet Jupiter, which we all know is the biggest planet, and I have us. Look how teeny we are compared to the sun. Now, it would make sense that the sun would have the most mass versus Earth. You can see it in the size comparison there. This is also why, because of its mass, the gravity is the biggest with the sun and it's able to hold all of the planets. Gravity is the force that governs the motion of our solar system. Think of it as the man in charge, okay? It's the one who rules the roost. It's the one who tells you who's going to move where and why. It keeps all of the planets in orbit around our sun, and I'm showing you the 8 big ones here. I didn't include the dwarf planets. So you'll see the sun in the middle. There's a fancy term for that. That is called the heliocentric model that you're seeing, and this is exactly what it looks like. Now you will notice that all of the planets here move or revolve at a different rate. Okay, so we know we revolve. It takes 1 year or 365.25 days for us to mosey around the sun once. Now the ones that are further out, like Saturn and Jupiter, you can tell take a longer time to mosey around. Look at the rates as they're going around. Look at Mercury, it's speeding right around, right? And then Mars, okay? So take a look at all of those, Venus included, and just watch this for a minute and watch the animation. So again, the reason why this happens is because the sun has the most mass and all of the planets are held in orbit around it. Now the orbit in this case is the path that it takes around the sun. Notice that each one has its own color, okay? And that's the path. All right, now we need to talk about distance. So gravity and distance have a relationship. The greater the distance, the less the pull of gravity. So when you're talking about our sun, its effect on Pluto is less than its effect on Mercury due to its distance. Now take a look at this diagram here. I would copy this into your notebook to help you remind you of this relationship.
You know that gravity is the force that keeps us from flying off the surface of the Earth, and you know that gravity pulls things not down, but towards the Earth's center. You also know that gravity exists between any objects that have mass, and the greater an object's mass is, the greater the effect of its gravity, or pull, on other objects is. But there's something more. Remember Isaac Newton, the apple tree guy? He determined that the amount of gravitational force, or pull, between two objects also depends on how far apart they are. So the farther away something is from the Earth, the less it will feel the pull of Earth's gravity. And the closer it gets to the moon, the more it will feel the moon's gravity pulling on it. So we can make the argument that two things affect the pull of gravity. First, the size of the object. Objects with a bigger mass have a stronger pull of gravity. And second, the distance between objects. The farther apart objects are, the weaker the pull of gravity between them. And the closer together they are, the stronger the pull of gravity.
All right, so the summary, what I hope you got out of this video is that gravity is a force that acts on anything with mass. The sun has the most mass in our solar system. It's the sun's gravity that keeps our planets in orbit around it. And then remember the two different relationships we have here. More mass equals more gravity. Otherwise, more distance equals less gravity. As always, thanks for watching, and I'll see you in class.